Hey, how's it going? I wanted to make a video talking through Note Set 5, just in case you're stuck at home and wanted to see some of the review of the stuff we've been learning in class lately. Most of these examples are going to involve not as pretty numbers. So we'll be dealing with fractions and that kind of fun stuff. So let's kick it off. Number one, they ask us to complete the square to write the problem in vertex form. So when we complete the square, our objective is to take out whatever number's in front of the x squared here from the first two. So we're taking 2 out of both of these, which actually works out pretty nicely. Like so. And that -1 is just going to chill in at the end. Alright? Then we're going to look at our middle term at the number part. So the number here is a 1. I don't really write it, but we're going to take that number and cut it in half and square it. So we take half of 1 and square it. Half of 1 is a half. And when we square that, we get 1/4. So we're going to put plus 1/4 here. And then we have to balance the equation. You can't just go randomly adding 1/4 wherever you feel like it. And in fact, we didn't even really add 1/4. We just wrote plus 1/4. There's a 2 on the outside that would distribute in, right? 2 times 1/4 is actually a half. 2/4 or a half. So we're going to take away on the outside 2/4 or 1/2. So that this and this together, those make 0. So we're still equivalent to what we started with, we're just writing it in a different form. And then factor. So the whole reason why we did that cut in half and square it thing is that makes this into a PST. This factor is real pretty as x plus 1/2 squared. And then we need a common denominator on the outside. Remember that 1 is the same thing as 2 over 2. So 2 and 1 makes 3. So 3 over 2. And now we're in vertex form. You can list out the transformations. This 2 in the front is a vertical stretch of 2. Going left to half. And down 3/2. So on our graph, we can go left to half, down 1.5, and then we'll draw in our axis of symmetry. So making a parabola, we know that the graph is symmetric across this line. And then the vertical stretch tells us that instead of going over 1 up 1, we're going over 1 up 2. Over 1 up 2. Over 1 up 2. Or over 2 up 8. Over 2 up 8. So the idea for this set of notes is meant to be a review of all of the other skills we've learned about in our first couple sets of notes. So in note set 4, we talked about horizontal stretch or compression. Note set 3, it's about vertical stretch or compression, which is affecting the graph here. And this is actually our first set of notes where we talk about finding roots when the roots aren't nice pretty numbers. So the idea is we're going to find the x-intercepts by plugging in 0 for our y value and then trying to solve for x. Okay, so I want to get the x by itself. So first we're going to add 3/2 to both sides. Multiply by a half on both sides to get rid of the 2. That gives us 3/4. And then to get rid of squares, square root it. And on the left side, we don't know the square root of 3, so we'll just leave that the way it is. We do know the square root of 4, That's 2. And we also learned that when you square root expressions that are squared with variables involved, you need absolute value. It's equal to the absolute value of x plus a half. Now remember back when we solved absolute value equations, we wrote a piecewise definition for what the absolute value equals. So recall that the piecewise definition looks something like this. And it reminds us that absolute value has 2 answers, one positive answer, one negative answer. So to get rid of the absolute value that we have here, we write a piecewise, and that tells us we can separate this into x plus a half equals the square root of 3 over 2, and then negative x plus a half equals the square root of 3 over 2. So we have a positive set and a negative set. And then the last step is to actually solve for x. So if we subtract a half, one of our answers is going to be negative a half plus the square root of 3 over 2. And then on the other set, if we divide by the negative and then subtract a half, we get negative a half minus the square root of 3 over 2. Right, those are our two, technically those are our two solutions, right? If you wanted to write them as x-intercepts, do that here, x-intercepts, because I kind of ran out of room. Let's go down the page. And we could say the x-intercepts are parentheses, negative a half, plus or minus the square root of 3 over 2, comma 0. I always write them as points. Let's write them as an x value, comma 0, comma a y value. Filling in the rest of this information from our graph, we said our vertex was left a half, down 3 halves, which makes our axis of symmetry that left a half part. So x equals negative a half. Domain is all reals. For the y-intercept, you're plugging in 0 for x, and it's usually very helpful to go back to standard form where we started, and the y-intercept is this number at the end, right? If you plug in 0 for these, you're just going to get negative 1. And that's matching up with our graph too. You can see that it looks like the y-intercept here is at negative 1. This particular graph has a minimum value, which is equal to the y value of the vertex, and our range goes from that minimum value upwards to infinity. Okay. So most of these examples are working this exact same style of problem again. I think. We'd like to make sure. Yeah, I'm seeing a lot of repetition here. But these first 4. First 4 in these set of notes are doing the same thing. Complete the square, put it in vertex form. So let me do one more of these with you as an example. We'll do question 4 here. So same process. We take out whatever's in front of the x squared from just the first 2 terms. So that 10 is left alone. Now if you take a half out of 5x, taking out a half is like multiplying by 2. So now we're going to have 10x here. Okay. We were trying to create a PST, so you look at your middle term, cut it in half and square it. So half of 10 is 5. 5 squared is 25. And then we want to balance it on the end. So we wrote plus 25. There's this half on the outside, right? That half multiplies this. So on the end, we want to subtract 25 over 2. Dropped my pencil. Okay. And then we can factor x minus 5 squared. 10 is the same thing as 20 over 2. So 20 minus 25 would be negative 5 halves. So our transformations, this time we have a vertical compression. We're going right 5. We're going down 5/2. So on our graph, right 5, down 5/2. That's our vertex. We can draw in the axis of symmetry, like so. And then our vertical compression of 1/2 tells us that we're going over 1 up 1/2. Or over 2 up 2. Think about that for a second. Over 2 up 2. That should be good enough. Sketching our graph. Like so. Come down here and find our stuff. We have a vertex at 5, -5/2. Our axis is x equals 5. Domains, all reals. This graph has a minimum, and its range goes from -5/2 to infinity. Our minimum is that lowest point on the graph, -5/2. For the y-intercept, we're going back to standard form, plugging in 0 for x. So 0, 0, 10. 10 is our y-intercept. Okay. And then from looking at the graphs, again, we have this problem of, we know that there are x-intercepts, they're just not at pretty numbers. So to find them, we have to use vertex form. Since we can see on the graph that our x-intercepts aren't at pretty numbers, that means that if we were to if we were to try to factor this with like trial and error, it's not going to work out very well, because we can see from the picture they don't cross at nice pretty whole numbers. So it's not going to factor with nice pretty whole numbers either. So we're stuck plugging in 0 and using vertex form like we did on the other side. Okay. So add 5/2 to the other side. Multiply everything by 2. Those cancel. 5 equals x minus 5 squared. Square root both sides. Recall that that gives us absolute value of x minus 5. Practice writing the piecewise definition. Again, we did this a lot in our very first chapter, so hopefully this comes back to you pretty quick. And that tells us that we can separate this into 2 different equations. Either x minus 5 equals the square root of 5, so we have a positive version, and then we have our negative version, where we have negative x minus 5. So if you add 5 to the other side, or distribute the negative, I guess I could have divided by a -2. It doesn't really matter. Something like this. So if it asks for solutions, you don't have to write it as a point. You can just say that our solutions are these x values. But if they ask you specifically for x-intercepts, we always like to try to write those as points on the graph, just so we're reminded of what we know. Okay, cool. That's 2 examples of that. Leaves 2 for you to go try. On the next page, it says graph the following, and you get to choose the best method. So when we learned about quadratics, we said that sometimes it's easier to factor, find the x-intercepts, find the middle. The middle tells you your axis of symmetry, which you can plug in and find the y value. Or sometimes it's easier to complete the square. So, or sometimes, if it's in vertex form, you can just do transformations. Right, so when you're looking at the question, you have to decide which method is most appropriate. In this one, since I'm looking at the middle term here, thinking about if we were completing the square, we would take out a 2, which gives us fractions to deal with. And then we have to cut this in half and square it. It gets really ugly very fast. So I'm more inclined to try factoring first. See if this factors with trial and error. Because if it does, it's a little faster to find the vertex that way. You don't have to deal with the ugly fractions as quickly. So factoring this, 2x and x, 20 could be 4 and 5. And if we had 8x and 5x, that can give us 3 if the 8 part is negative and the 5 part's positive. We can get negative 3 in the middle. So 8 parts negative, 5 parts positive. So setting those things equal to 0, we get that the x values are at negative 5 halves or positive 4. So positive 4 is here. Negative 5 halves is here. So either way, you're going to have to deal with fractions at some point, but we can at least get a nice pretty starting on this, right? It's not hard to factor. It's not hard to set equal to 0. We now have something to go on. Next, we need to figure out what's the distance between these, because we know that the axis of symmetry is going to be halfway. So these are currently 4, 5, 6.5 units apart. So we need to find 3 1/4. That's half of 6.5. So if you go over 3 1/4, we'll be here. So 1/4 of the way from 1 to 0 would be at 0.75, or 3/4. 0.75 or 3/4. That's our axis. And then we want to figure out where the y value goes. So we need to plug in 3/4 for x. So what is f of 3/4? We plug in 3/4 for x. We'll have to deal with some fractions here a little bit. So 2 times 3 would be 6/4. And if we grab a common denominator here, that could be 6/4, and 5 times 4 is 20, so 20/4, and 3/4 and 16/4. So we get 26 over 4 and negative 13 over 4. This reduces to be 13 over 2. So when we multiply here, we're going to get negative 169 over 8. That's our y value. That's going to be way off the graph, right? Because 8 goes into 160 20 times. It's like 21 and 1/8. So we're going down 21 and 1/8 on this line, which is hard to draw because our graph only goes to negative 8. So sometimes what I'll do is I'll just put a point down here and we'll label it. I know that point is my vertex, and its x value is at 3/4, and we found its y value to be negative 169 over 8. We really only need 3 points to make a graph, so draw your graph in. It's not perfectly to scale or anything like that, but it's labeled. Okay. Looks like a parabola. That's good enough. So you have to be able to look at a problem and decide, like, what's the best method? Do I want to solve by factoring? Do I want to complete the square? Can I just do transformations? So there's some examples that we practice on that. And those continue on to the back with a few more of you getting to choose what method to do. I'm going to do one more example, number 9. This is in a vertex form. So we may want to do transformations as our method. But recall, when you have a number in front of the x, you have to factor it out, like so. And then list your transformations. At 2 there is a horizontal compression. That 2 here is going left 2 and then down 4. So if we go left 2 and down 4, and then we're compressed horizontally, so over a half up 1, or over 1 up 4. Draw on your axis. Very quick to graph these if you're using transformations, especially if it's already in vertex form, because then you don't have to do any work. Alright, cool. Hope that's helpful. If you have any homework questions, feel free to email me and I'll make a video of those too. Alright, see ya.